Well, I've been delving quite deeply into quantum physics and dealing with the concept of superposition. And I'll explain superposition in the way that I see it. And it all really has a lot to do with what determines a particle or wave to be the way we find it. Okay, that I emphasize the way we find it because what we know is what we find in our experiments. We do not have direct communication as to what goes on in the microscopic world. Now, if let's take a particle like an electron, and let's determine that it can be in space A or it can be in space B, and there's an equal chance of it being in either one. We find that it has an equal chance because we've done a lot of experiments, and we get those results: 50% in space A and 50% in space B. But now let's think about it a little bit. We cannot predict whether the electron is going to be in A or B. One reason could be that it's very predictable, and there are variables that will give away that information, but we're just not paying attention to them. So that there, I think, the reason for the particle being in a probabilistic state, as far as we're concerned, is our ignorance. We're simply not doing an experiment correctly. Well, let's get a little deeper. Now, the reason could be that there are variables that would determine whether the particle is in electron or is in state A versus state B, but that information is not available to us. We haven't done the experimentation. We simply assume that they exist, but we don't know. They're hidden variables. And so now the particle has a probability of being found in state A, and it has a probability of being found in state B. Let's say it's 50% each. We are not. It's not ignorance. It's just that a lack of knowledge. There are hidden variables. There are forces at work in the universe that are determining which space it'll be in, but we are totally unaware of those hidden variables, and so we still have to deal with the situation probabilistically. Now, superdeterminism plays into the situation I just mentioned. It assumes that there are hidden variables that I suppose it's probable that some of them or one of them could be found, that new variables could be found. Whether there would give us a complete explanation of a particle's state, I doubt it. Now there's an even deeper level to our probabilistic situation, and that's where there are no hidden variables, and there are no variables available to us where we can determine whether the particle is in state A or space B or state B. And also there is nothing really. Now I'm dealing with this situation metaphysically. There's nothing in the particle's history that would tell us whether it's in state A or state B, space A or space B. Well, that's getting a little deep. It's saying that there's nothing in the universe, even the universe does not know the status of this particle. There is absolutely nothing that goes to determine whether it would be in state A or state B. It is at this point that we use the concept of superposition because we have no other choice. The particle, as far as we're concerned, as far as the universe is concerned, can be in A or B, and they're both equally likely, and it won't be in either state until we make a measurement. Once we make the measurement, yes, it'll be found in just one state, either be in state A or state B. It won't be in both. But before we make the measurement, there's nothing, absolutely nothing in the universe to help us determine whether it's in state A or state B. So therefore, the best way to conceive of that is an example of superposition. Where we don't have to get too vivid about imagining particles being in multiple places at the same time, or having multiple spin up and spin down at the same time. No, I won't worry about that so much. Most of the concepts that we use to describe what's going on in the microscopic world, in terms of quantum physics, is an attempt to take macroscopic concepts like wave, concepts like particle, and concepts like momentum and energy, and these concepts are sort of pictures that we place over the fundamental reality that we are measuring, and these pictures help us understand the phenomenon. But we got to be careful. I see a lot of hype going on about quantum superposition, and people getting very mystical and very mysterious about that. My quantum nature is mysterious, but let's stay with what we can measure, and let's not our imaginations get too far away from that. Amen.